Okay, hello. Okay, this meeting is being, the recording has stopped. This meeting is being recorded. That's definitely an example of a sentence which means the exact opposite if you hear it in the wrong order, or a pair of sentences. Right, so it is being, can you guys hear me? Wait, you cannot see me. I cannot see myself. Well, I can see myself, but not that way. Hold on, sorry. Okay. All right, so I think we're all here. So hello, good morning, good morning. I still can't. We're getting straight back. We're going to keep doing what we're doing. I will say, having met with Professor Walters for a long time last night, and having had a great with both Professor Walters last night, and having caught up on a lot of matters. Um, They thought you might want to know, we will actually have an exam in this semester. It will be a midterm exam. It will be before the final exam. It will be in 2 weeks from today. I don't want to get bogged down in it today. You will have a total practice exam before it, which will count for nothing except for you to practice. You will get solutions to that practice exam. What's the other thing? The actual exam itself will be like remarkably similar to the practice exam, so that if you really do know the practice exam and have worked it out in advance, which is the idea, then you really will not be surprised by anything in the exam. And again, I don't want to get too bogged down now, but right. Oh, and the exam will probably be take home. But we'll get into those details like toward the end, like on Wednesday of this week or next week. It'll be 2 weeks, but just if you want to plan, it will be 2 weeks from today. I think is what we're saying. Yes, 2 weeks from today. But we will have plenty of time to, and it will contain this material that we've been doing. But let's just keep. But I think people are getting what we're doing. We're going to keep doing it, which is this vector stuff. So here, we're just going to. And I'm starting to turn back stuff also. But if you haven't gotten stuff, you will very shortly. Okay. Okay. Oh, I'm sorry. I was about to start you off on a new do now, but I just realized, I believe in this class, didn't we just, and I'll confirm this, I'm confirming with you, and this is like everything is a 50-point question, so to speak. I was about to introduce a new vector problem in this class, but I believe, was it not this class where we just, where oh, no, I guess it was not. No, we do need a fresh new vector problem. We have, in this class, we have not added three vectors together yet, right? As boring as that sounds when I just say it like that, but no, okay, thank you very much, right? And that was 50 good. All right, so I do want to do, so I want to pick up right from where we were last time. We were doing displacement vectors. We're going to add three vectors right now. If you get what's going on, you'll think of it as like just a boring, like, well, duh, okay, it's three instead of two, and you'd be right in a way, but then we know we've mastered this. But if you try to like brute force your way through a two vector addition problem, then the methods really fall apart and fail you once there's three. So three is the rubber hitting the road with vectors. So we're going to do one quick addition of three displacement vectors problem. That, again, that's the topic we're doing right now, is addition of displacement vectors. And we're strictly speaking going to add three of them, and then start applying that to velocities and accelerations. But so here we go. Okay. I'm going to look in the chat in a second, although it may just be where I think the chat. Okay, I think that's where it doesn't say. This is the whole problem. Again, these are all the givens. It doesn't explicitly state the question. I'm going to explicitly state the question, but you know what the question is if you're following along what's going on. Like what I'm giving you here is what I'm giving you all here is 3 separate displacement vectors. Each one of them is a magnitude, or should be a magnitude, and has a direction. Each one has its own magnitude and direction. Like the directions are not relative to each other. They are just directions in a plane with a compass. And the question is, given these 3, if these 3 actions were performed in a sequence, what would be the total displacement? Oh, someone's in there. How far away do I end up from my initial starting spot, and precisely in what direction? So I'm going to write this down again, but like if you get what's going on, then the question is simply the question is add these up. What's the sum? The question is what's total displacement. But what I want to make clear to everybody, and I am taking a little long to say the question, because it does take a little while to solve the question. Like this question, the answer that it's inviting is just complicated enough that, for example, I know I can't do it in my head. I'm not pretending I'm holding this answer while I'm asking this question. I will get it in a minute, but it's so the answer, for example, is not 10 plus 20 plus 30. Like it's not 60. And your final answer, this again, just to remind everybody, and then I will shut up. And again, you can all think this through out loud. Like you should talk out steps that you don't have to just be done with it before you say anything. Although you also can do that. But just know that what we're looking for at the end here, what would mean moving on to the next question, the end will be a total displacement. I mean, the end result, the answer will be a total displacement, which means a magnitude, a number of meters, and a direction, which will be an angle with points of the compass. Like a final answer would be like 50 meters at 37 degrees southwest. That would be and you could maybe guess your way to what the words are going to be in the compass direction by feeling this out, but you can't guess the angle and you can't guess the magnitude. Like it's just complicated enough that and so you shouldn't feel like you have to, or you shouldn't feel like you're missing something if you don't. You have to work this through with pictures of triangles. But so this is the question again. We're all going to work on it, and you can think out loud. It helps people, or you cannot. But I will welcome any input on this, including answers or steps or questions until we get to the answer. And I will rewrite on the next page smaller in a moment. Mhm. Sorry. Oh, sorry. Okay. So I was just sending some things back to you and I'm seeing the chat. Oh, okay. Sorry, I missed. Okay, wait. So I can definitely go back, but wait, did I make an error? The 20-meter hour is supposed to be south. Oh, eeks. It is supposed to be going southeast. That is a mistake. Thank you. Oh, and someone asked me privately. And see, that is about saving my embarrassment, which is very nice of that person to. But no, wait. There's a mistake in the diagram, and I'm being asked to go back to the original question anyway. Okay, and someone has an answer. That's awesome. And by the way, I appreciate. So thank you for the private chat. Thank you for that correction. That definitely, if it was private to save me, that's very nice of you. But okay, but anyway, that's totally point worthy. Let me put it that way. The person that put the correction or the question about my diagram, even though it was in the private, please do submit that for 50 points. Like I totally get why you put that in the private, and but it's totally helpful. So yeah, this is the question. This is the correct question. I totally appreciate that Justin is saying publicly that he has an answer, but like not literally saying the answer while he says that. That is very considerate of everybody who's still thinking. I totally want to hear some details from him and or anybody else in a moment. Let me make sure though that I didn't screw up the question with that diagram. I mean, I have an answer too. I mean, I'm ready to go. Wait, in both cases, did I say southeast? Yeah, 20 meters at 30 degrees southeast. That is what I mean to say. I do mean to say southeast for the second direction. I did not mean to draw it southwest. And did I draw it? But that, so I'll fix that. That was luckily not a mistake in my drawing where I got the answer, so it doesn't change my, right, it does not change my answer. But yes, good point. This should be going like that, 20, right, like that. Which means that diagram down here is weird. That explains also why. Yeah, that explains why I was having trouble with that diagram actually. So this diagram should be, and what I want to hear from Justin in a second, if he wants to, is, wait, what do we say? Right. Right, and we're looking for, okay. It's totally up to Justin. So I think it's great that Justin said he has an answer and didn't like actually say what it is. And the funny thing about a problem that's this kind of problem, again, is a real like rubber from the road, hit the road problem, because it's just complex enough that it can't sort of be faked really, and it can't really be gotten by luck accident. So the thing is that works in reverse. Even if Justin says the answer, it's not a spoiler. I want everybody to know he can say the answer, and all that can really do is make anybody who, and assuming he's right, let's say, or he can check it with me, and then we'll both feel good if it's the same answer. But if we're not up to that answer yet, it doesn't really give away anything. And if we got a different answer, maybe it tells us something has to be resolved somewhere. But that's a funny thing. Like you can't really work backwards from the answers with these problems. So I think what I'm getting at is, so he's gonna do it. Right. So I totally appreciate that. He's even asking me, do I want it privately or publicly? I will, it's whatever makes, in that case, whatever makes Justin more comfortable. By the time you say, I'll take it either way. And Irma, sorry. And maybe I did it. So hopefully, I guess, Justin, hold the answer for a second, I guess. But what I like really about this class and this discussion, I do think that, especially given everybody does things at their own pace, obviously, and it can get frustrating in either direction. But can I assume that everybody does think that they are looking at the same question? Like I did make a mistake in that diagram, and it was great that someone brought that up in the private chat. Oh, right. That's what I'm still looking at, I think. But assuming that I fixed that, are we all understanding the problem the same way? And again, if anybody needs more time, they can still take more time, even if someone posts an answer. It's not a competition that way. But I'm trying to say that the vectors go straight north, then a longer one at southeast, and then a still longer one at northeast. That is what I'm trying to say. I guess, Justin, I'll take the answer privately, I guess, just to see where we're at. So to see if you need to do something more before. if you can hear me. Right. Okay. Okay. Cool. 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 I'm looking. Oh, interesting. Okay. 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 And I could say this too. There's been a little more stuff in the private chat from other people too. So now I can safely say that that there's just enough precision in the chat. There's enough specific mathematical detail in the private chat, and enough unresolved precise detail, like numbers are specific, but numbers are different between a couple of people in the private chat. That means to me that we're just not totally resolved. Like I'm going to check my work now, and everybody can. But again, if anybody wants to, it could be someone who thinks they have an answer or someone who doesn't have an answer. Like this is a journey. I don't mean every problem to be solved of any real reality takes steps, right? So it's super helpful for anybody to want to share whatever step they're on. Like, in other words, by the time I'm going over the steps, I go over the steps all in one big vomit that's both too long and boring and too fast and unified to actually help people that want to see from one step to the next. So talking out the steps is really what I'm saying is anybody who's at a step that they think is right, they might want to share the thing they think is right, and they don't have to share where they're stuck. They can just share what they think is right. It might unstick somebody else. But I'm going to recheck my work right now. And I will say the way I do my work, if this is a hint to anybody, the way I do this is those diagrams that I drew on the next page were like for reference. But the diagrams I privately make to solve this, which I will then publicly share, I literally do solve this by diagrams. And the way I do is I take each vector and I make it into its own right triangle. I make it into its own hypotenuse of its own right triangle. If it doesn't look like a hypotenuse, I can't find the other two legs, it means I don't even have to do that to that one. But I make each vector into its own right triangle and I make an XY chart. That is how that's what I'm going to share with everybody when I'm done. But that's what I'm checking right now. And if you know even how to start that, that would be a good, but I'll shut up. And it is 30. And it's not one big 30, 60, 90 triangle or anything like that. Well, just, yeah. Oh, no, I see where I made a mistake. I did make a mistake. I did make a mistake. Which doesn't, so, Still. Huh. Wow. Now, all right. I'm going to say this now. Okay. um, oh, no, I see again. Yeah, I think we're converging on an answer here. There's increasing agreement in the private chat for anybody who knows. And the person that's disagreeing in the private chat is me. And I'm increasingly in the minority and increasingly believing that I'm crazy. And I think they're right. But I'll say anything. So if there's points involved here, I'm getting none of them. Yes, I totally agree with the answer. Wow. I totally do agree with the answers that are now in the private chat. And I totally, again, and there is more than one person in the private chat giving me full answers with distances. And one of them is obviously just, sorry. Yes, it's exactly who anybody would think based on reading the public chat. Those answers are correct, which is awesome. So can I ask, if either Armin or Justin or anybody else wants to start, is it possible for either of you guys to share a a diagram from your side? Or but their answer, I mean, I haven't published the answer. I'm sorry. The answer that they're saying, or does either of you guys, or does anybody, I hate this so much. Yes, Justin and Armin are saying 41.5, I'll write this down, but 41.5 meters, which I agree with now. I got something, I'm sorry. Oh, yes. Okay, great. Cool. And they got, so they got an answer, and I'm going to try to talk this in a bit. I want to see if I can get a different version, not just me but yes, I agree that the total answer for the total here, I'll and that is awesome. No, it is impressive, especially. And someone's here, sorry. And here's this, there are things I can say about this even. Again, of course, we're going to talk through this problem. We're not going to move on until we're sort of clear that everybody kind of at least has a fair shot at understanding how to solve a thing like this. And again, that does mean that some people that are solving it faster may, and the reason I keep encouraging people who are getting answers faster to try to talk it through to others or share is because really I do secretly know, if nothing else, that benefits them so much. Like it really helps to talk this stuff through, and it also helps you from feeling like you're not learning something or whatever. But things I can say about this before you just get another walkthrough by me is notice these answers. If you do this kind of problem correctly, you can sort of tell this is a real science problem in the sense that I'm literally saying my answers are approximate. Like I am going to get a slightly different answer from either of them two or any of you in the room. And all of our answers, if we're being honest, proper scientists and doing this right, we're saying our answers are approximate, approximately 41.5 meters, like meaning that there's more digits to follow that 5, but I'm choosing to chop them off at the 5, and someone else might choose to chop them off at the 3 or blah, blah, blah. And at an angle of 38.8 degrees northeast. Now the northeast is exact. Like I am guaranteeing, and so are the two guys that got so is anybody who got these answers. I'm guaranteeing that the answer's in that quadrant, that the way you have to walk, the way you've walked at the end of the day is somewhat north and somewhat east. I am saying it's like less than 45 degrees. It's 38.8 degrees. Again, though, it is proper and exact to say that we are being approximate here. And we're not being approximate because we're being loose, right? We're not being approximate because we're being casual and we're not sure. What we're sure is that we're dealing with square roots of irrational numbers and things like that. or we're dealing with irrational numbers and things like that, so that literally our measuring instruments cannot handle the full infinite expansion of digits required to express these numbers. So we are saying we're only going to get these numbers sort of so precisely, but as precisely as our instruments would ever care about. But we're choosing to write the numbers this way. Like, I'm not writing that my final answer is like square root of 40 over 2 or something. I could do that if that were a math problem, but that doesn't really help me. What I mean by 41.5 meters, even though I use an approximate equal sign, I mean that's the actual number that you could find on a meter stick that you could relate to in real life. Like, I'm really saying if someone walks 10 and then they walk 20 and then they walk 30 meters, if they were to walk that all straight in a line, they'd walk 60 meters, right? 10 plus 20 plus 30. That would be 60 meters. They would end up far away from where they started. But if we allow for motion in the plane, if you walk 10 and then 20 and then 30, you really have to pay attention to what directions you're going to know how far overall you progressed. And we're saying with these angles, if you go 10 and then 20 and then 30, you end up north of where you started, because every one of those things, because most of those things took you north more than they took you south. You end up east because those things took you more east than they took you west. But you end up not 60 meters from where you started, you end up at like 41 meters because you did some backtracking with those angles. That is what we are saying. Now I'm going to, so that, awesome. Hold on one second. So I think we're going to get maybe better. It looks like we might get a break from my usual. Just so I think someone's going to try to share. I don't know why I'm being so euphemistic about this, but yeah, Justin's going to try to share his picture if it works, which would be great. But what I'll also say while we're waiting for that, actually, wait, we're just going to pause for a second. Oh yeah, well that's true. I thought I could. Okay, I thought mine was just on. Okay, sorry. Yes, hold on. Sorry. Sorry, I'll turn off mine. Sorry. Okay. Aha. Oh, wow. Oh, that was worth waiting. Oh my God, that was totally worth asking for, or whatever awkwardness. That is beautiful. Oh my God. All right. So what? Okay. Hopefully you can. Well, presumably you can, because I can see this. Okay, this is really nice. I mean, and again, I know it's always a risk if I'm going to talk a lot about like one individual. That means I'm talking about that person, not other people, and I apologize. Like that's weird, but really anything that can come from you guys rather than me is so much more worth it. This is really beautiful. This has a lot going on at the same time. In fact, now I notice he's sort of doing both at the same time. He has one big picture of the whole situation that we literally, and it's careful enough and it's on graph paper enough that we could trace out the answer physically. Like we could actually find the answer to this whole problem by measuring on his diagram. But also he's got, I think it looks like, yeah, wow. He has got, right, with each one of the vectors, he has divided it into two components. Now wait, can I actually, let me see if, one second. I want to see if I can. Okay. So the one thing I would add to this, if it were possible, or I would ask it, or something, or on exam or whatever. Oh wait, no, it does have it. It's just hard to see. I think he does have arrowheads, I think, which are super important to me. The arrowheads on each triangle side to indicate direction. But okay, if we start with his black line that says walk. He gives the directions at the top left, walk 10 meters north. So we start at the black vertical line that's going 10 meters north. Now, in my mind, I'm imagining, and the one, again, improvement or whatever I would suggest is, in my mind, there's a clear arrowhead at the top of that 10 north pointing vector. So we go straight up north. Then from the top of that, we go 20 meters southeast. So that next black line is an arrow pointing south, i.e. down the page and to the right. And then from there, we go the 30 meters northeast, the final black line. So his black lines are the vectors that we're adding together here. Those three vectors technically we're adding. And the answer to the whole problem that we're getting is the length and direction of that purple line. Like that's what this diagram is saying. Like the purple line is the answer to the question for the sum formed by the black lines. Now, the thing that's really important about this diagram that I'm glad he shared that that you literally can't solve the problem without his orange and yellow lines or whatever color, whatever color they show up on your side. Like, but if you look, because there's a lot going on here. So I want everybody to focus, like, look at each black line separately as its own vector. Each black line that's labeled, like one is labeled 10 north, one is labeled really nicely 20 southeast, one is labeled 30 northeast. If you look at each one of those vectors, each one of those, he is treating as the hypotenuse of its own right triangle. He's finding what the legs would be if that vector were the hypotenuse of its own triangle. And that's what we always do every time with all vectors, even when you can't see why you would do it necessarily right away. The whole point is that, and this is where the arrows come in for me, but I'm focusing hard on his 20 southeast black line. And again, it's really helpful that he did it. And hopefully we'll do this with other people next time or whatever. I don't want to make it overly formalized, but I even if it's a strain for everybody to listen or to look, and even if I apologize, like it should be him explaining his own work, obviously, but in a way I want to say to everybody, me sitting here trying to explain his picture, I think is more beneficial than you guys trying to make sense out of my pictures or whatever, because this is close, because it shows what's actually underlying the whole thing, regardless of whether it's my personality or someone else's or whatever. Like, so the black lines are the action. Sorry, just letting someone in. The black lines are the vectors. And if I look at that really clear black line that says 20 southeast on it, and the one that's heading down and to the right, if I look at that, he has treated it as a hypotenuse of he's like made it into its own right triangle. Notice, I think why I'm excited, what I'm trying to say, like he changes color, puts this orange thing in there. Why? Because he has to make those legs that he made for the right triangle formed by the 20 southeast, he had to make. They're not presented to us in the route taken by going 10 meters and 20 meters. Like the vectors don't form the right triangle. This is a big common error that people make, especially on exams if they haven't practiced themselves before. They kind of know what to do with right triangles from math class, so they think they're going to see the right triangles in the physics situation and then go from there. But no, you actually have to force them in. That's what he's doing. He's take the orange two legs of that black hypotenuse, 20 southeast. What they're expressing is if you go 20 meters to the southeast, what you've actually done is gone 17.32, like approximately, meters to the east, and then you've gone 10 meters to the south, or you went 10 to the south and then 17 to the east. But that southeast is the sum of south plus east. Again, here I would put arrowheads on just to be, okay, the teacher about it. And what I would very specifically do, by the way, everybody, those two, and if you can possibly add it on your, I don't think I can, I don't think I can annotate or whatever, but like if you look at his two, and I'm just to show the ideal, if you look at his two orange lines, the two orange legs of the 20 southeast triangle, like strictly speaking, what it is that orange 17.32 leg, the horizontal leg, the top leg, that is pointing to the east. That's pointing to the right. That's an arrow that should really have an arrowhead at the end of it. Like it should have a tip all the way at the eastern tip of that. And then from that tip starts the tail of a southward pointing arrow, which will then have its tip at the bottom. In other words, can I do this? I don't want to go back. I don't want to risk it. But, oh wait, I can. Wait, can I? Wait a minute. Hold on. Oh no, it's on his. I see. All right, sorry. But if you imagine arrowheads, one that makes the orange leg, the horizontal one, not just be horizontal, but specifically point east. and one that makes the vertical one not just loosely vertical, but specifically points south, then what, I knew, wait, I think the man is, I knew it. I knew he was going to take my not at all subtle hint. This is a human being who knows how to communicate, ladies and gentlemen. Hey, the guy gets an A for physics and diplomacy. No, and so does everybody else, and the love, but that's great. Okay, I really appreciate it. I think it's very awkward that I'm sitting here constructive, being critical to something so fine. But yes, now that is right. And now if you, thank you very much. I appreciate it. If you look at that now, it's super, what it's literally saying that the way we add vectors is by first breaking up each vector into a smaller addition problem. In vector land, we literally do, as you can maybe start to see from his picture, the way we add 5 plus 2 is we first go to ourselves, wait, what's 5? Oh, 5 is 3 plus 2. And we lay out sticks on the ground and add them all together. So he's got, what we're saying here is 20 southeast is really 17.3 east plus 10 south. Okay, and I'm going to say that again because, well, I'll say it again with the other vector then, and I'm going to say it again at the end. I'm literally saying to everybody, what you can really see with the arrows is that southeast really equals east plus south. Technically, it also equals south plus east, but I'm on purpose saying always think of southeast as either meaning south of east or meaning east plus south. Like we always, horizontals, we always add them first. You'll see what I mean if you go to his next vector, the 30 northeast, that long black arrow that now has a really nice arrowhead, it's pointing northeast. What he's saying, oh wait, you didn't put it in. Okay, what we could put in there is a similar thing. We could say that 30 northeast is really some amount east, in this case 15, plus some amount north, in this case 25.98. And by the way, of course, all those numbers he got from Sokoto, oh yeah, you can see he totally provides in the blue, which is awesome. But okay, I'm actually going to skip off this diagram for a moment. Just wait, am I home? So no, first thing I'm saying then is that how we actually solve this problem, or first thing he's saying is you take each one of those black vectors, each one of the given vectors, you break it up into a horizontal piece and a vertical piece. You break it up to an X component and a Y component. Those components themselves, like the X component will point either east or west. I would take seriously into account which way it points, first with an arrowhead and then ultimately with a negative or positive sign. And what we're going to do with all those pieces, with all those components, what he's done, he's gotten all the X and Y pieces of all of these long hypotenuses, and then we just tally them up in an XY chart. So I'm going to knock off his, I really appreciate it. I think this is great. And I hope other people do this too. I'm going to go back to, I'm going to go back. Thank you. All right. And I'm going to just, one thing about his diagram, it's literally, it's so nice and comprehensive. It is neat and clear and huge and contains everything. It might even be intimidating to some of us, say me. I mean, I can't speak for anybody else, but I don't even draw that, like my things don't look like that. For that and the other reason, and that I have to live with that. But what that also means is partly what's intimidating to me is I can't actually visualize that all at once. When I break up the vectors into components, so I'm going to do this now, I zoom in. What I'm about to do is just is entirely consistent with what he just did. In fact, yeah, I don't even want to repeat. But each of those hypotenuses that he broke up into components, he did it all in one picture. I do it in separate pictures myself. But the result, and I'm sure this is the result of what Armand did as well, and check out his diagram next time. The result is that we get a running tally of all these X and Y numbers. And this is where I will ask someone to correct me if this is different from what, I think this is exactly what he and Armand said, but, and there's rounding in the digits, but I think what we end up getting is this, or approximately, right? And this is a running tally. There's specifically three rows here because there's 3 vectors, and there's 2 columns because we're in a 2-dimensional situation. There's 2 columns because there's 2 dimensions, 2 components to each vector. Sorry. And where that negative, the one negative sign in there comes from that one, and this was a correction that someone made to that one negative sign is that one place where I say southeast rather than northeast. If I had said north, then that negative would be a positive. If I had said southwest, or as my diagram mistakenly indicated, if I had said southwest, then the X number, the 17.3, should also be negative. Oh, problem. Sorry. Oh, okay, fair enough. Okay. Fair enough. And maybe totally understood. But and Armin, as long as you're, and thank you for saying that, would you are the numbers in your table essentially consistent with these numbers in my table? Or if you hear that or check it out, let me know. But because I think these are the numbers. And again, it's literally we are gonna cool, awesome. All right, thank you. Notice to everybody, because not all problems in like this is what's weird about this is we're literally learning addition right now. Like literally we are learning addition, but we're learning addition in n-dimensional space. So it's a technique, just like, when you learn addition of numbers in second grade or whatever, it's not a joke. Like it's not an easy thing when you first learn it at all. In fact, it's very, very abstract. Eventually you get used to it. Well, this is back to basics in that sense. We're literally learning how to add directional quantities, and it involves the addition of numbers, but it involves more than that. But therefore, this is an addition problem. There are also subtraction problems, multiplication problems, division problems. We have to learn that too in physics, honestly. This is an addition problem. So I'm like, I walked and then I walked and then I walked. So I'm going to add up all these numbers. I'm literally going to add them up because it's an addition problem. But whether each one of them is positive or negative totally comes from the original vectors themselves, i.e. the picture. This is why I'm very strict about like, I want to have arrowheads all the time, because this one -10, I know to make negative. I know to make, and I know that Armin and Justin got it right. Like obviously their way works for them. But if I'm looking for a way that's always going to work for everybody all the time, like I only know that 10 is negative because one of my arrows specifically pointed down, like it pointed down to the right. And when I made components out of it, the vertical component pointed down the page, and that tells me negative. And that's how we know. So you have to make the negative positive decision independently of whether you're adding or subtracting decision. But once you make that decision, so then we got this, I think we got some like, something like this. And then this is specifically positive, and this is specifically like, one of these answers could have ended up negative, but the negative numbers weren't big enough, so it didn't. Are these my numbers? Yeah. Now, what did I do last? Again, same thing that I know Armin did, same thing I know Justin did, but I'm going to do it on my piece of paper here for everybody, because this gets into now what I mean by when I say southeast, or in this case, north. Like I know my final answer is going to be some kind of northeasternly pointing answer. It's going to point north because my final Y tally up was positive, and it's going to point east because my final X tally up was positive. So it's going to be some north. What does that mean? It really means east, some amount east plus some amount north, by which I mean this. I am going to draw on the next. I'm going to draw the final result. It's like something that goes east about 26.3 meters, right? And then I'm adding tip to tail. Something goes east that far, and then, are these the right numbers? Yeah. And then it goes north a bit farther, like 32 or whatever. Not much farther, but a bit farther, like 32 or whatever it is, 0.0 meters. Right? Something goes east and then it goes north. How far northeast did it go? That's the thing I'm looking for. Like this thing is the answer. But the reason I'm making a big deal of saying, notice the way, if you keep the arrowheads consistent, then and if you always draw the horizontal first, what I'm trying to say is always draw the horizontal first. I know my answer is going to be somewhat east and somewhat north. And I know the way I drew these columns, like I draw. Oh, did I just do it back? Oh, I keep saying, I'm so sorry. I see what I did. I'm so fixated on drawing the horizontal first, I double psyched myself. Sorry. Still the same point though. So but definitely draw the horizontal first. It's still the same. I mean, obviously, it's still basically the same triangle, but I'm saying draw the horizontal first. Then from the tip of the horizontal, draw the tail of the vertical. That is your right angle there. And the reason I'm making a big stink of drawing it first is then necessarily the angle you'll get here between the tails, this angle between the tails is the angle you'll want. Like this angle here, the arc tangent of opposite over adjacent. This angle, which is approximately, what is it? I don't remember now. Approximately, yeah, 39. This answer, this theta, is, to my mind, definitively a northeast angle. Like it's showing what it should show. The angle between the tails, the angle that we end up going overall is north of east because it's the equivalent of going east and then north. Like you could, in other words, you could take the last, you've got to practice this because you don't see how many, one doesn't see how many choices there are until, oh, it's 12. Okay. Until one tries to make the choices. But like what I'm saying is, if you don't include arrows, it's easy also to think at the end, like, oh, it's easy to think. You might do that. You might say, oh, here's my triangle. I've got a 26 and a 32. And that would be legitimate mathematically. Like you, in other words, if you don't even put in the arrowheads at all, if you're just like, oh, here are my two final answers of my column, a 26 and a 32, and I just put them together. And so I know I'm looking for that final leg, that hypotenuse. It's very frequently people will do that, like, and do the Pythagorean theorem correctly. They're still putting in the right numbers. 32 squared plus 26.3 squared equals a square root, and they'll get this final leg. But the problem, if you just do that, if you don't actually track the arrowheads, or if you don't actually draw horizontals tip to tail and then verticals, you get this triangle here. And what angle are you looking for here? Like what gets really confusing is this is when people will then suddenly stress in the middle of a test, like, wait, I don't know which angle I'm looking for. I could get either one from SOHCAHTOA, but I don't know which one is the right one. And the reason they're confused is because like neither one is really the right one. Like this angle here looks like what you'd be looking for because it's kind of like, oh, that's where I started my vectors. It's kind of like the angle between the tails. Oh, if I started here, if I went somewhat up and I went somewhat over, I guess I went up over. So it's this angle, but that's not the right answer. Like if you actually did SOHCAHTOA to that, you would find that it's the complement to 38 degrees. Like that's not the right answer. You're going to get something like 52 degrees there because what that angle right here, this blue, and I'm talking a lot right now about what would be wrong. And nobody did this wrong. But it does happen all the time for not doing all the steps. If you don't put in the arrowheads or you're not careful about taking basically I'm saying take each component, break it up into take each vector, break it up into its own components, tally up all the components, then put your tally up results together in one big right triangle. And when you do that, I'm literally saying, always draw the horizontal leg and from that, draw the vertical leg. Go understand that all right triangles are themselves tip to tail sums of a horizontal with a vertical. And if you draw the horizontal first, then the angle to solve for will be self-evident. But if you don't draw the horizontal first, then you end up solving for these kind of angles. And that angle there is not anything northeast. That is east-north, if you really think about it. Like that is how far something went east of north. So your calculator will spit out 52, which would be confusing. And you wouldn't, and the other one is 52, but no one would think to solve for that. Doesn't look right at all because it's not where you ended up going. It's where you ended up being. All right, enough of that. But I'm very impressed that, so a number of people definitely got the right answer, which is awesome. You all slogging through this. I think Justin's diagram helped a lot. I think, oh, and I'm starting to send you, hopefully you're seeing anything you're saying in class, you're getting 50 points. Oh, that just reminded me. You're getting 50 points for, but that just reminded me. I know we only have 2 minutes left, but in the 2 minutes, all I'm going to do is make sure there's an assignment portal up today for anybody to submit anything they did today. I'm starting to send back the ones from the last videos. You'll see, I just put a quick comment on your comment, but you'll start seeing the points coming. So let me just put that assignment right now for everybody, but that's all I got we'll just pick up with this Wednesday. Hold on. Sorry. Or I'm sorry, you guys don't have, I'm just gonna hang here for a second to make sure this portal is in, I mean, this assignment is in your portal, but you can go or not as you see. Right. Anybody who said anything today, please do submit, of course. Bye. Good to see you. Bye. Thank you, guys. Um, Thank you. Thank you. Have a good day. Thank you. All right, I'm going to shut this down. So the other, thank you guys for waiting. Hopefully you got the thing in your assignment portal. I'm totally shutting this down. Thank you guys.